With SSR apps built on Next.js, Nuxt.js, or SvelteKit, engineers typically route every page request all the way to node or bun. That's the default approach recommended by the official docs, so it's used almost everywhere. But here's the catch. Rendering pages on the backend is expensive. Every request means running JavaScript and turning virtual components into HTML. And all of that work happens on the same server, shared by every user. Then it gets worse. A request can end up waiting on a slow database query, or on an API that's waiting on a slow database query of its own. Most real-world apps put a reverse proxy in front of their SSR instance, usually to route API traffic elsewhere or distribute the load. But that alone does not make anything faster. The request still ends up in Node.js, while the proxy simply waits for the response and passes it back to the browser. Developers may also run several Node.js processes, or replicas. That helps the system handle more requests at once, but it doesn't make a single request any faster. Every one of them still pays the full cost of server-side rendering. Software engineers often add a CDN like Cloudflare in front of the reverse proxy. And yes, it can make static assets load much faster, helping SSR apps during hydration when JavaScript takes over the HTML rendered by the server. For pure SPA apps built with React, Vue, or Svelte, a CDN works even better because most of the application can be served directly as static assets. But dynamic content is a different story. Cloudflare can cache it, technically, but the limitations make it hard to rely on for a meaningful performance boost. In the end, the actual page content, the core request behind every page load, still has to reach SSR, even with a CDN in front. The irony is that most SSR content barely changes at all. Landing pages, blogs, contact forms, e-commerce listings, most of them stay the same for quite a while. Even for an e-commerce item where the in-stock count may change soon, showing content that is 30 seconds old is rarely a problem. And if some data really needs to be real-time, like exchange rates or that in-stock count, JavaScript can update it after hydration on the client side, for example via WebSocket, without re-rendering the whole page on every request. And this is where Wait0 changes the game. Wait0 is an open-source caching proxy that remembers the last rendered response and serves it instantly, without waking up Node.js at all. Instead of paying the full cost of SSR again and again, Wait0 serves ready-to-go HTML through a highly efficient Go binary, making responses incredibly fast. You stay in control of the resources. For example, allocate 200 megabytes of RAM for maximum speed and 1 gigabyte of disk for overflow. Wait0 uses RAM first, then seamlessly falls back to disk. And it doesn't stop there. Wait0 uses Stale-While-Revalidate, so even when cached content becomes stale, users still get an instant response while Wait0 refreshes it in the background. Fast now, fresh on the next request. Pure SWR has one drawback though. Once a request expires, refreshing requires the page to be hit twice. The first request serves stale content, and the next one serves fresh content. With high traffic, this issue is not noticeable, but it still exists. That is why Wait0 ships with WarmUp mechanics. If WarmUp is enabled, Wait0 starts fetching all known URLs in the background. You define a budget, like how many requests per second maximum, and how long to wait between loops. This provides fresh and fast content at the same time, updated frequently. But this works only for known URLs. Once Wait0 restarts, it resets the list of known URLs and the cache. But you can persist it using the URL persister module. You can go even further and enable the sitemap module, which discovers URLs from your sitemap and starts warming them up, so requests stay fresh and fast. As a bonus, you get a dashboard with memory usage and useful SSR statistics. By the way, the Wait0 is fully agent-friendly. Just ask your coding agent to add Wait0 to your existing DevOps pipeline and see it in action. Of course, fast HTML is only part of a fast web application. Hydration, JavaScript size, and client-side performance matter just as much, and that is exactly the kind of speed we build for at Dev4th. Wait0 by Dev4th, built to keep the web fast.